Welcome to today's webinar. The topic today is design of FRC structural elements in concrete design add-on. My name is Andreas Hörold. I'm responsible for marketing and PR in the company Dluba Software. For instance, the website, the German and English webinars, newsletters, and so on. I will be the moderator today and will answer your questions together with Alexander. Yeah, but my two colleagues can introduce themselves.
Hello everyone, my name is Paul Kieloch. I'm working as a support engineer at Dluba Software, and I'm working on a support hotline and also on the development. In terms of the development, especially for concrete design, and in context of concrete design, I'm happy to show you today new features in the concrete design add-on for designing fiber reinforced concrete slabs today. Yeah.
Good afternoon, also from my side. My name is Alexander Meyerhofer. I'm responsible for the development of concrete design in RFEM and also working on the geotechnical development, geotechnical analysis module. I will answer today your questions in the chat.
Okay, thank you for your introduction. Then we can switch off the webcam that the attendees can see the full screen. For the attendees who participate the first time, you see a control panel on the right side of your screen. Usually you can show it with that arrow, and then can you enter a question here and we will answer you. You can also watch the full webinar and then email questions to info@dlubal.com. To the agenda today, Paul will activate the fiber reinforced concrete design, and by creating a new material type, and then he will model and design the structure components and do a design of the ultimate and serviceability limit state. Okay, then I hand over the screen to Paul. Paul, it's your turn.
Okay, thanks, Andreas. I would like to start at first with a short overview of this steel building, because I would like to design a slab for this steel building actually, and for this I would like to use two separate files. So one file is the steel building, which gives me the support forces or support reactions. And then I will create a slab and transform these support reactions as loads into the other file. Therefore, I will show you a new feature in the load wizard, which was implemented some weeks ago. So that will be also quite interesting for you, I guess. And then I will do the concrete design with the fiber reinforced concrete material. So maybe just as a short overview in this structure, I have here these nodal supports on which I will get support reactions. These support reactions will give me the loads for the slab, and I have here basically 6 load cases, self-weight snow, and 4 load cases for the wind load. What's maybe also important to mention is the numbering here of the nodal supports or nodes. I will use this numbering also in our second file in which I will enter the slab. So therefore I will create a new file. What's now important is that the steel building and the new file for the slab are in the same project folder in our Dluba Center. That's important regarding the new option in the load wizard to overtake the support reactions as load. I will come back to this topic later and mention this a second time. Now I'll just enter the name here. That will be foundation slab, and I will activate the concrete design add-on. So what I will show you today is basically part of the concrete design add-on. So we will create a material that's fiber concrete material or fiber concrete, and the design itself is running in the add-on for concrete design. For the standard, I will use the national annex for Germany, but these features, which I will show you today, or the design approach and the equations are also part of the other national annexes for the Eurocode 2. Okay, that's basically all. Just one topic I have to check is the Lose Wizards, that it was activated because we will need it afterwards. That looks good. Can confirm it. And then this new file was created, and I will switch back to the structure with the steel building, or file with the steel building, and I will select my nodes here, and with Control C and Control V I can import it here, copy and paste. So we have now the position of our nodes with the columns from the steel hall, and I do not need here the lines and also not the nodal supports. So I can delete the lines here, then open here this chapter types for nodes. Then we have here the nodal supports, and I can delete them as well. And what we now got is just here the nodes for the columns. And if I do a right click and activate the numbering, then we see here exactly the same numbers like in our file with the steel building. That will be important afterwards if we transmit or transform the support reactions to nodal loads. Okay. I will switch off the numbering just to have a clear overview of the structure. Next topic is creating the material for the slab. So I'm entering a new material, go to the library, and then I can select here this fiber concrete. Fiber concrete was already implemented also in previous versions. So it was already possible for you to create a slab with material type fiber concrete. But what's now new in the latest state is that slabs with the material type fiber concrete are now also considered in the concrete design add-on. So basically that is the new feature what I would like to show you today. So I'm setting up the filters here and select this material. Okay, and now you see here this material type fiber concrete. And if that material was assigned to a slab, then the program or the add-on concrete design knows that it has to use the approaches for fiber concrete or fiber reinforced concrete material in the add-on. Now, if you would like to edit the material properties for the fiber concrete, then you can switch to the tab Material Values. And at the bottom end of this tab, you find here Steel Fiber Properties. And in this tab here, or in this chapter of this tab, you find here especially the performance classes L1, L2, and these classes are defined by your type of fiber that you have assigned or that you would like to use for your design checks. So basically, the type of the shape of these fibers, the material of these fibers, etc., it gives you the classes L1 and L2. And you can modify this, and this will define the strengths of your fiber concrete. By default, this was set L1 to 1.2 and L2 to 0.9. If you would like to modify that, you can click here on the main menu and activate user-defined material, and then this is accessible and you can change it. The values itself, they come from the guideline from the German Committee for Concrete Design, or Deutscher Ausschuss für Stahlbetonbau. They released a guideline for fiber reinforced concrete, and there you find more information regarding these clauses. But I will stay here today with the default values and use this one. The next material that I need from the example that today is steel, reinforcing steel. Therefore, I'm setting up these filters once again, and then we can select here reinforcing steel, this one, and I will use this B500 here. And afterwards, I will do also a comparison between this fiber concrete and a normal concrete. Therefore, I will just create a normal concrete material, concrete and Eurocode, and this one here. Okay, so basically I have both concrete materials, C2025, but the first one is including fibers or fiber reinforcement, and the material here, the third one, is a regular concrete material. Confirm that was okay. And the next topic I need to enter is a slab or a thickness for the slab, and that will be 240 millimeters once with this concrete, fiber concrete, and for the comparison with the regular concrete. Okay. So now we could import or enter the slab. I would like to have a space of the edge of the slab to the center of the columns of 30 centimeters. To enter it graphically, I just modify here the grid. Therefore, I'm entering here 0.3 and 0.3 in both directions. Confirm that with OK. And now I can enter here the slab with the thickness of 240 millimeters and the fiber concrete material. Click on OK. And then we have the first point here and the second one on the other end. And here I just have to modify the origin of the grid, and then it looks like this. And the slab was entered. And just to have a better overview, a clearer overview, I will switch off the grid and also the snapping points of the grid. Okay. Next topic is modification of the slab itself. So we will at first enter here supports. I will use here a surface support with random stiffness. I could probably also enter here a solid with the geotechnical analysis add-on, but that would be from more time intensive. So I'm just using here random spring constant for this example today. Enter it. The next topics would be here regarding these chapters for concrete design. So we have to check here our concrete covering. I will use here at the top side XC3, and at the bottom side I will create a new one, and this should be XC2. And if you now wonder why these values won't be applied here, that's because the surface reinforcement is missing. I will just enter it here with a mesh. use this mesh here from the German product range. If I confirm that and go back here to the concrete cover, then you see that the concrete covering was applied correctly here. What I have to change or modify in the tab with the design configuration is regarding the serviceability configuration. If I'm designing a foundation slab, then I can think about changing the setting regarding the AS-min calculation due to restraint. In my example, I would like to use pure tension restraint. So I'm switching this option here to pure tension restraint. And what's also possible, or at least in according to the German National Annex and the commented version of the German National Annex, it is, for example, possible to reduce the tensile strength of the concrete by a certain factor. It's depending on the thickness of the slab. And according to the German National Annex, it would be possible to reduce here or use the reduction factor of 0.65 for slabs up to a thickness of 30 centimeters. So I will do so for this example. For this example, I would like to deactivate the deflection analysis because that's not required here. And I will also deactivate the automatic increasing of the longitudinal reinforcement here for serviceability. So that's basically all I have to change here in the serviceability config. I confirm that once again, and then we see here our slab already with the reinforcement. Just to have a better overview, I'm deactivating here the reinforcement so we see our pure concrete slab. Okay, the next topic I have to enter is the FE mesh refinement on the nodes. So I'm switching maybe to this view. I'm selecting all the nodes on which I would like to apply the load afterwards, and I will assign here a FE mesh refinement, and therefore I will use here this rectangular one with a target length of 5 centimeters here in the first element next to the node. Okay, this one, okay. And what I would like to activate in the same way is here the check for punching. If I do so, then this tab here appears with the configuration for punching. And in this example, we have to check the configuration regarding punching because we do not have entered here any columns. So the program has no information about the section dimensions. So in the current setting, it would not be able, or the program would not be able to generate the perimeters for the punching. So therefore I can define here a loaded area, and I would use here for these nodes 25 centimeters in both directions. So with this setting I will be also able to do the design checks even if I do not have entered a cross section here for the columns. Okay. That looks good. We'll confirm that. Okay. If I switch to the wireframe display mode, then we see here these nodal FE mesh refinement. I will deactivate them. And if I generate the FE mesh, yeah, then we see that all refinements were activated or considered correctly. And the last topic I have to enter here regarding the FE mesh is in the special objects, the surface result adjustment. I would like to use here smoothed results inside a certain result adjustment. So I will enter them here for the slab number 1. and they will have a dimension of 0.5 meters, and the first one is here. Can confirm that. And now I can select it, click on copy 3 times from that point to that point. Okay. And then I will take these here and copy them also 3 times, but this time from this point here to this point. Okay. And then I will select these two. Just one copy from that point to that. So, okay. And the surface result adjustments are now entered. I can just check whether they were applied. Yeah, looks good. So just to have a clear overview, I can deactivate here the mesh and also switch to the result objects and deactivate here the surface result adjustments. Okay. That looks quite good so far. So I will just save the file and now take care about the loading. As I have already shown you in the steel structure, we have here 6 load cases from the steel structure. I will enter them here, so therefore I'm opening this dialog. The first one is self-weight, it's okay. Already the second one was the snow. Snow, then we have wind in plus X. Okay, and then I can just make plus Y. Then minus X and Y. So these are the load cases from our steel structure, and I will add also a 7th load case, and that will be the live load on the slab, and therefore I'm using here storage areas. Okay. Regarding the actions, that was filled correctly here automatically. Then regarding the design situations, I do not need here this frequent, so I will delete it just to reduce the amount of calculation time. And before the load combinations will be generated, I can take a look at the action combinations. And just to avoid calculation time or too much calculation time in today's example, I will just activate these action combinations where all 4 action categories are active. The other one I will deactivate. So it looks like this. And if I click on the load combinations, then I have basically these load combinations to consider today for the webinar. Okay, that's all so far. So we can confirm that. The next step is now to import the support reactions from the steel structure into this file with the slab. Therefore, I'm going to the load wizard, and if I open here this chapter for the load wizard, maybe I'm just shutting down this a little bit, that it's better for overview. If you go to the load wizard, then you find here a new option, import support reactions. So that is a new option since the version 6.3. Then we can create here a new load wizard, and now you can find here in this tab model all the models inside a project folder or in the same project folder for where also is the foundation slab stored. So I have my steel hall in the same folder as the foundation slab, so the steel hall is here accessible. Then I can switch to the objects and enter here that I would like to use the supported or the support reactions of the nodes 1 to 12. I have the same numbering, so I can directly enter 1 to 12 here and then switch to loading. Click here on automatically, and the program automatically finds the amount of load cases from which I can import support reactions as I load into this file. As you may know from RFEM 5, there was it just possible to import vertical loads. In RFEM 6, it's now possible to import also the horizontal forces and also the moments. I do not have entered moments here, or I have hinged support, so for me it's okay just to activate here the horizontal forces in X, Y direction and the vertical force in Z direction. Then I can click on OK, and maybe I switch to the serve weight. What you now see here is the imported load. In this state, you just see here these question marks. That comes from the fact that the program does not know in this state the value of the load. That will be calculated now if I hit the button for the calculation. Then the program will at first calculate the support reactions in the steel structure once again. So you see it here, steel hall, steel structure, and then it will import the loadings to our foundation slab file. So both files are now combined together. So if I would update anything on the loading of the steel hall, the program would automatically update here this loading. That's also new compared to RFEM 5. In RFEM 5, this was a free nodal load. Now it's a object load, so a nodal load, and is also it's always in context to a certain node, so that we can also use it for the punching. And it is now, or both files are now connected together regarding the update process. So that is new in RFEM 6 now. Basically, that was everything regarding the modeling of the structure and the load. We have also our combination done so far. So I can go over to the add-on concrete design and just check the input data here. I'm going over to objects to design. And what's important now here is to check that to design the slab is number 1, that's okay. And our nodes 1 to 12 are active here or displayed in this column to design. So that's also a hint that the input data was correct and the nodes are correctly activated for design. With these settings, I can basically start the calculation of the add-on. So you see now here, once again, this batch for load. That means that in the first step, the program will calculate the original file where we would like to import the support reactions, import these support reactions as loads, and then do the usual calculation step here in calculating the internal forces of the slab, and now the concrete design add-on. I guess that should be done in some seconds. And now we should be able to check the results here. So maybe I'm switching off the reinforcement here and also the design checks on nodes, and we take care about the surface results at first. So I will open here this results navigator, and maybe also the serviceability and ultimate limit state, because what the program actually does is it modifies the already existing equations according to from the Eurocode 2 according to this mentioned design guideline from the German Committee of Concrete Design, and that means that the equations of the Eurocodes will be modified or extended according to this guideline, and that's also the reason why we need a reinforcement here. So if you do the design in the concrete design add-on, then it's currently not possible to do the design just with fiber concrete without a regular longitudinal reinforcement. So you always need a regular surface reinforcement for the slabs, or if you would do this for the members, then you would need a longitudinal reinforcement or a shear reinforcement, and the program would then just modify the equations from the Eurocode in terms of the fiber concrete or fiber reinforced concrete material. So if we go through this individual design checks, let's say we take at first a look at the ultimate limit state. If I activate it here, then we see that basically it is a problem of punching, I would say, here in this example. But I would like to show you this because if I open here this detailed results, then you see here, for example, this little F here as a index, and this shows you here the shear capacity in consideration of this fiber reinforced concrete. So every time you see here this small f, then it means that this is in consideration of this fiber reinforced concrete. If I would switch here to this intermediate result, then you see it here in the panel here that these values are a little bit lower. So that is here the result or the shear capacity without this fiber, and this one would here including these fibers. Okay, so the fiber reinforced concrete will be considered for the ultimate limit state design checks and also for the serviceability. Maybe I'm switching over to the serviceability. There it's the same. So here in this example, all the design checks are fulfilled here now for this example. What's for such slabs, maybe the most decisive result is here the minimum reinforcement due to restraint. And in this example, I'm almost at 90%. And I can also check here the required amount of reinforcement due to this restraint, and there you see exactly the same like for the ultimate limit state. You see here this small f, and this shows you that this is in this minimum reinforcement is in consideration of this fiber reinforced concrete. I will do afterwards a comparison of fiber reinforced concrete and normal concrete. The last point I would like to show you here regarding the results navigator is the results for the punching. So as I said before, for this slab, the punching is maybe one of the decisive design checks. And for the punching, if I'm switching off the results on the slab and activate it here on the nodes, for the punching, it is basically the same. You have here also the small f, which shows you that this fiber reinforced concrete material will also be considered in the design checks for punching here. That's regarding the results navigator. If you would like to check it in more in a more detailed way, then you can switch over here to the design ratios on surfaces, for example. And if we go here to the shear capacity or shear resistance design check, for example, do a double click, then you see here these equations, and this is here, as I said before, that this the short expression for the Deutscher Ausschuss für Stahlbetonbau, so the German Committee for Concrete Design. And basically here you have the information how this guideline modifies the original equation from the Eurocode. So that's also important to know, because, as I said before, it is a modification of a regular reinforced slab, just with consideration of fiber reinforced concrete material. So you see here these equations which are used for the design checks. That's for the shear capacity, and the same is also for the, I have to check where we find it, and the design ratios and surfaces. Here for the serviceability, yeah, for the minimum reinforcement, it's the same. So I can, yeah, show you these results here. There we have the same. If I would like to check here how the program is calculating the amount of required reinforcement due to restraint in consideration of this fiber reinforced concrete, then I can also go here to the design check details. And if we go here down a little bit, then you find here, as I already mentioned here, this guideline, the chapter in the Eurocode, then the equation of the guideline, and here you find how the program is calculating the minimum reinforcement due to restraint, and with the small letter f in consideration of this fiber reinforced concrete. Okay, that's regarding the results here. I guess that is pretty straightforward. So it is basically like you already know it from the regular results from the concrete design add-on. Now to have a comparison between the material with fibers and the regular concrete, I would like to divide this slab in two parts. And therefore, I'm creating here just a line in the middle of the slab. And then I can do a right click on the surface and divide this. And now if I switch on the numbering, then we see that the slab number 1 was now changed to slab number 2 and 3. That means that I have to take care about my special objects and the surface result adjustments, because they are assigned to a certain slab. So they are all still assigned to the slab number 1. Therefore, I can select here this first half. It is now, or it should be now assigned to slab number 2. And this here to slab number 3. Okay, apply. And now they are in black again, so they are again considered correctly. What we also have to check is our material. I'm going over to the thicknesses. So the thickness number 1 is still used for both slabs. So I open here the edit surface dialog for the slab number 3 and just change here the thickness to this one. And then this slab number 3, will use our regular concrete material, and the slab number 2 will use our fiber reinforced concrete material here for the design check. We see also here in the table of the add-on and in the input data that we now have here the slabs number 2 and 3. So that seems to be okay so far. We have still our 12 punching nodes here assigned. That looks also quite good. So I can directly hit the button to calculate the results once again. So, and it's the same step as before. The program will update the loading from our steel hole and do the design in the concrete design add-on once again. So we have also the statical analysis once again and the concrete design once again. Okay, let's check here the results on the surfaces, and I will go now to the required reinforcement here on the top side, maybe in direction 1. And now you see here the effect of the slab with fiber reinforced concrete, and here the regular concrete. So on the right side we now need more reinforcement. That is basically in all directions the case. Here the values are pretty small because of the loading. In such examples, like for this foundation slab, the minimum reinforcement due to the restraint will be the most decisive result, I guess. So we can switch over to our serviceability results here. And if I click here on the design check for the minimum reinforcement due to restraint, we see now that on the left side, our design check is fulfilled with almost 90%. So it's the same value as before. But now on the right side, due to the fact that I did not consider here on the right side this fiber reinforced concrete, but just the regular one, on the right side, the design check for the minimum reinforcement due to restraint is now not fulfilled. So that is maybe a small example how you could use this fiber reinforced concrete material. That's basically already the end of my today's presentation. I will just give you one hint regarding slabs that are not reinforced. That is maybe also a quite common user case. So the approaches today are based basically on the equations of the regular Eurocode. And as I said before, we are just modifying these equations of the Eurocode 2 according to this guideline of the German Committee for Concrete Design. If you have slabs without regular longitudinal reinforcement and you would like to design them just with fiber reinforced concrete, then it's also possible, but then not inside the concrete design add-on. Then you can create a new material type, and this material type would be damage, the damage model. And then you can do a nonlinear calculation and do the design checks by analyzing the strains and stresses for the material with material model damage. We have some webinars, or not webinars, some knowledge articles on our website regarding this topic, and they are also linked to our event page for this today webinar. So if you need further information regarding this material model damage, then you will find it on our website for the today's event. And the last hint I would like to give you is everything that I have shown you today for these labs is also possible for the members. So I have shown you this for these labs because from my point of view, it's the maybe one of the most common use cases to use fiber reinforced concrete for slabs. But you can also do this in the same way for members if you would like to do so. That's all from my point, and I would hand over the screen back to Andreas.
Okay, thank you, Paul, for this nice presentation. I would like to show you the website with where you can find the recording and the mentioned links and the presentation slides. Before I do it, I would like to give you a hint. If you want to book your free online appointment, such a presentation of an add-on or of a product from us, from our software company, RFEM, RSTAB, RWind, etc. Just book this appointment by our sales team with that link here, or you can scan the QR code. Also, if you would like to get a non-binding offer, then you can also contact our sales team. I switch to the website. That's our website, lubal.com, and under news and events, you can find the webinars. And that's today's webinar. That's the common webinars. This webinar in 2 weeks will be presented by Paul as well. Our section, or you can define our sections and design them in RFEM 6. He will present that webinar. That's today's webinar. I click on it and you will get an email when the recording is online. You will find the recording in the middle here. Then you will find the presentation slides here and the mentioned links. And you can already find the model files here. Those are the model files from the German webinars, but we are the same. Okay, that should be all also from my side. Thank you for your attention. Thanks to Paul for this presentation. Thanks to Alexander for answering the questions. I wish all a nice rest of the day. Bye-bye.
Ciao.